Hi everybody, this is Miss Bufford, and in this video we're going to talk about scientific notation. Your learning goals for this video are to be able to write a number in scientific notation and explain why it's important in science. So we use scientific notation in science a lot because often scientists have to deal with very large or very small numbers. Writing them in scientific notation is a way for people to deal with those numbers more easily. So usually we're able to take a really long number and compress it into a smaller number. So here is an example of a number that's written in scientific notation. This portion in the front, we call that the coefficient, and the coefficient will always contain all of the significant digits that were in the original number, and only the significant digits. And then the exponent back here indicates how many places we would have had to move the decimal to the left or the right. And we'll talk a little bit more about how we get that number here in just a minute. All right, so what are the steps to writing a number in scientific notation? The first step is that we want to move the decimal either to the right or left so that the final number is between 1 and 10. And if that number has no decimal, like our example number over here, then we want to place a decimal at the end of that number. That's just a phantom decimal because we need something to be able to count those spaces and to be able to get a number between 1 and 10. All right, then we're going to drop all of the leading and trailing zeros unless those trailing zeros are significant. So remember, in our coefficient, we want to keep all of the digits that are significant. And then step 3, we're going to write times 10 to the power of a number, and that number is going to be equal to the number of spaces that we moved the decimal. And we'll take a look at this last part here in just a minute, but let's go ahead and look at this example. So here we go, we've put our phantom decimal in there, and now we're moving our decimal to the left to get it to be a number between 1 and 10, and we ended up having to move it 8 spaces. So now we dropped our trailing zeros because they were not significant, and then we added times 10 to the 8th. And remember, that 8 right here comes from the number of spaces we had to move that decimal. So let's take a look at this last part right down here. Decimal movement to the left is going to make the exponent a positive number. So in this case, we had to move our decimal to the left, and so that 8 is going to be a positive 8. But if we're starting with a really tiny number and we have to move our decimal to the left in order to get it to be a number between 1 and 10, then our exponent is going to be negative. And we're going to talk more about that on the next slide. All right, so let's talk about when how to know which direction we need to move the decimal. So if we're starting with this really tiny number right here, then we know that in order to get this number between 1 and 10, we're going to have to move the decimal this way, right? So we're moving the decimal to the right 7 spaces in order to get that to be 5 instead of 0.00000005. Right, so in this case, we have to move the decimal to the right, and so our exponent is going to be negative, okay? And another way of looking at this is if we're starting with a really tiny number like that, then we know we're going to have a negative exponent. If you can just remember that small numbers have negative exponents when they're in scientific notation, then if you're ever in a situation where you have to convert from scientific notation to the expanded form, then you can look at that and say, oh, well, that's supposed to be a really tiny number because it's a negative exponent. So I think for me, it's easier to remember if I've got a negative exponent, that's going to be a super tiny number. And then over here, if I have a positive exponent, that's going to be a larger number. It's going to be greater than 1. So that instead of remembering whether you're supposed to go left or right when you're converting either way, it's just easier to associate negative numbers with tiny expanded form numbers and positive exponents with larger expanded form numbers. And then same thing over here. In this case, we're moving our decimal over to the left, which is going to give us that positive exponent. But if you remember positive exponent, that's a big number. Then you know which direction you need to move your decimal in order to get that number to be a big number. So let's go ahead and do some practice. Go ahead and pause the video and give these a try, and then we'll come back and do them together. Okay, so this first one right here, remember we don't have a decimal, so I'm going to have to put a decimal down at the end. And because there was no decimal, none of these trailing zeros are going to be significant, so they're not going to end up in our final number. So I need to move my decimal to the left. And that was 1, 2, 3, 4, 5, 6, 7 spaces. And so that is going to give me a positive exponent. All right, so 2 times 10 to the 7th power. All right, let's do this second one over here. I have a decimal in this number, which means that I need to figure out how many of these are significant. And it looks like they're all significant. Trailing zeros in a number with a decimal will be significant. So they all need to be in my coefficient. So I'm going to move the decimal still so that I get a number between 1 and 10. So 1, 2, 3. And that means I'm going to end up with 3.00540 times 10. And I moved it to the left again to the 3rd power. So there we go. There's my answer there. And so you can see that sometimes if we have numbers where all of the digits are significant, it's not always helpful to write it in scientific notation. In this case, it actually had made us have to write more. So that's just something to kind of think about when we're writing these in scientific notation. All right, so let's go ahead and do the third one. This one has no decimal, so these are not significant. But I do need to put my phantom decimal there, so I need to figure out what this is going to be, a number between 1 and 10. 1, 2, 3, 4. And so I end up with 5.63 times 10, and I'm moving it over to the left again, so it's going to be a positive 4. So 5.63 times 10 to the 4th. And remember, we did not include these zeros because they're not significant. There was no decimal in the original number. All right, so let's go ahead and do this one. So now we're having to move the decimal. Since we're starting off with a tiny number, we're having to move the decimal in the opposite direction, which means our exponents are going to be negative. So remember how I said to associate small numbers with that negative exponent when they're written in scientific notation. So 1, 2, 3, 4, 5. And that gives me a number between 1 and 10, 9.83. All right, 9.83 times 10 to the negative 5th. So there we go, there's my answer. And then this one right here, we're just going to move the decimal 1 space because all the other digits, they're significant, and that's how I get that number between 1 and 10. So my answer is 1.0078 times 10 to the negative 1st power. And then in this case, we have to go ahead and move that decimal over to the left again, 1, 2. And you can see that these are all going to be significant digits, so they all have to be accounted for in our coefficient. And so there we go. We had to move it 2 spaces, so 4.580009 times 10 to the 2nd power. All right. Now what we're going to do is we're going to practice converting from scientific notation into standard notation. So go ahead and pause the video one more time and see if you can go backwards. And try to remember the rule of thumb where if you've got a negative exponent, then that number is a really small number in expanded form. And if you have a positive exponent, then that number is going to be a really large number in expanded form. And that kind of helps you remember which direction you need to move the decimal. So go ahead and pause it, and we'll be right back to work through those. Okay, so this first one right here is obviously going to be a really tiny number because it's got a -9. So I need to be able to write this in a way where I've got, I'm moving the decimal, to make this a smaller and smaller number. So I'm going to put 0 here. 1, 2, 3, 4, 5, 6, 7, 8, and then I have that 2, 6, 5, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9th spot. And so that is my number in expanded form. And remember, that's a tiny number and a negative exponent. All right, next one, I've got a positive exponent, so I know this is going to be a larger number. And so I'm going to have to move the decimal the opposite direction. So 8.94, and I need to move that 4 decimal space, or 4 spaces, 1, 2, 3, 4. So I need 2 zeros there. And there we go, 89,400. All right, so this third one, I'm going to kind of go ahead and write that up here again. So I have 2, well, actually, we're doing something different here. Let me clear my markings. All right, so again, -3. So what I'm going to do is I'm going to start with a 0 here, 0 point. And then I need to move that decimal 3 places. So I'm going to put 2 zeros and then 2, 0, 9, 0. So 1, 2, 3, just to double check. So there we go. There's my final answer. And this one is positive. So I know that's going to be a large number. And really, I'm only moving this decimal 2 places over. So that ends up being 930.2. And then this is a negative number again, so that's going to be a really small number. So 0.0123, and then the 5th spot right there, 0.94, 2, 3, 4, 5. And so there we go. There's my final answer. And then this last one right here, that's going to be a super tiny number, and it's got a lot of significant digits there. So we're going to start 0.1, 2, 3, 4, 5, 6, 1, 1, 2, 3, 4, 5, 5. So there we go. There's our final answer for that one. All right, I hope this video was helpful. If you have questions, don't hesitate to contact me either through email or through It's Learning, or I'll see you in class. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.